Okay, so an example discussing vertical asymptotes of functions here. So what are the vertical asymptotes of the function f of x equals 1 over x plus 2? Okay, so first of all, a function can only have, a rational function, which is the kind we're going to be looking at here, can only have a vertical asymptote when the denominator is 0. Okay, it doesn't have to have one there, but it can. Okay, so if you look at this function, it's very simple, 1 over x plus 2. The denominator can only be 0 if x is negative 2. Okay, so the question is that a vertical asymptote? Well, to answer that, we need to look at two limits. We need to see what x approaches, what the function approaches when x approaches negative 2 from the right, and when x approaches negative 2 from the left. Okay, so let's talk about x approaching negative 2 from the right. Okay, now there's nothing we can do to simplify this function, so we're not going to be able to use direct substitution here. If you put negative 2 in for x, you just get 1 over 0, which is undefined. Okay, so what I did here is just make a table. If I pick numbers which are getting close to negative 2 from the right, okay, these are numbers a little bit more positive than negative 2, like, for instance, if this is negative 2 and this is negative 1, okay, numbers that are close to negative 2 from the right are going to be like negative 1.9, negative 1.99, etc. So I picked a few of those numbers to kind of see what the pattern is, and of course if I get close to negative 2 from the right side, I see that the function is getting very large and positive. So in this case, it seems that the limit as x approaches negative 2 from the right is infinity, because as I get closer and closer to negative 2 from the right side of that number, the function value is getting larger and larger. It's not approaching anything, it's just growing huge, so positive infinity. Now over here, I am approaching negative 2 from the left, and I see that I am approaching, or I'm getting out of the function larger and larger negative numbers. Right, so I picked a few numbers, negative 2.1, negative 2.01, negative 2.001, put those into the function, and what do I see coming out? I see very large negative function values, so we believe that the function's approaching negative infinity. Okay, so there definitely is an asymptote, a vertical asymptote, when x is negative 2. And in fact, by computing these limits, and now I'll erase the table here, getting that those two limits and figuring out what they are, we really know a lot about the graph of the function. For instance, negative 2 is right here. Okay, we know that our function is going to have a vertical asymptote there. Now, from the right side, the function approaches positive infinity. So regardless of what the graph looks like exactly, we don't know everything yet. We know that it's going to be approach positive infinity. So we don't know exactly what happens over here, but we do know that the function has to be curving up towards the asymptote on the right side because the limit is positive infinity. Okay, this statement says literally, when x gets close to negative 2, the y value coming out is getting larger and larger. So the function will curve up towards the asymptote on the right side because the limit's positive infinity. Now on the left side of the asymptote, it could also curve up, but in this case it curves down because as x approaches negative 2 from the left side, the limit is negative infinity. So if I put numbers closer and closer to negative 2 in, they have to be getting larger and larger negative. So again, with what's happening over here exactly we don't know, but we do know it curves down towards the asymptote on the left. It curves up towards the asymptote on the right side.